Welcome back. So here we're given the problem f of x equals x squared minus 4x plus 4, and g of x equals negative x squared plus 4x plus 4. And our task is to find the area that falls between the two curves. So to be able to do this, we're going to have to graph our functions. So either using a graphing calculator or using a graphing device that I'm going to use here, which is, by the way, a free website and a free app called Desmos. You can go to it online through a website by just going to desmos.com. I'm going to put my two equations in here. So first up again is the equation x squared minus 4x plus 4. So this green graph here, that's going to be my f function, and g, which is negative x squared plus 4x plus 4. Okay, so the blue graph there, the purplish graph. And let me just maybe zoom out just a little bit here so we can see things. And then we can now see what the area looks like. Right? We can see here that we're dealing with, they intersect here. It's important to know where they intersect. Now we could do this by hand, but the nice thing is here, at least especially on this Desmos, I can very easily click and get that point of intersection. X is 0, y is 4, and then they also intersect again over here at 4, 4. So we definitely need to know where it is. We're going to be integrating right now along the x-axis. We also need to recognize the top function, which is actually going to be this bluish function, purplish blue function here, will be our top function over the interval. And this green function will actually be our bottom function. So f is actually the bottom function here. Okay, so we're going to take this. Recognize the endpoints. That's important. We're going from x equals 0 to x equals 4. So I'm just going to paste that graph in here so that we can use it. We see the area that we want to work with. Right? And we need to think about what it's going to look like when we approximate it with a rectangle. So just kind of draw in a generic little rectangle here. I'm just going to draw one in here. It won't look perfect, but it'll be enough to make it kind of clear. We can see that throughout the whole interval, right, throughout the whole area that we're dealing with, the blue graph is always on top. And the green graph is always on the bottom. So our formula is always going to be, in this case, g minus f. Sometimes you'll have ones where one function's on top for a bit and they switch. And we'll see some examples of that later. But here g is on top. And we can see again that we're going from 0 to 4. 0 to 4 along the x-axis. So we set up our integral. And so here our integral would be the integral from 0 to 4 of g minus f in this case, because g is the top function. So negative x squared plus 4x plus 4, g minus f of x. X squared minus 4x plus 4 dx. And then we just start to work this out. So I'm going to do a little bit here without writing everything down. As I distribute my negative through, that's going to make that minus x squared. So I'm going to have a negative x squared and a minus x squared. So this is going to be the integral from 0 to 4 of negative 2x squared. Then I'm going to have a plus 4x and another plus 4x. So that'll be plus 8x. And then I'm going to have 4 minus 4. All right, they both just go away. So the constant terms here cancel out. and that's just dx. And then we just go through. This doesn't require any kind of substitution type thing. This is just a straight power rule integral that we're going to eventually evaluate as a definite interval. So we can use our power rule. So remember how it works. I'm going to add 1 to the exponent, make it 3, divide by it, so that'll be negative 2/3 x cubed. And for 8x, I would add 1 to it, make it x squared, divide by it, so that'll be plus 4x squared. And then evaluate at our 2 endpoints, 0 to 4. And so we go in and we compute that. If we plug 4 in, first off, we would have 4 to the third, which would be 64, times 2. So negative 128 thirds. And then plug 4 in again. 4 squared times 4 would be just plus 64. And then minus, plug 0 into both of those, it's going to be 0. And we just simplify the arithmetic here, and we will get 64 thirds. Okay, so now we know the area that falls beneath that graph. The area that falls beneath that graph is actually between the two, not beneath that graph, but rather between those two graphs is 64 thirds. I know for sure exactly what that area between those two regions is. 64 thirds. 64 thirds. Okay, so again, we're going to continue with some other examples. As I said, we will have sometimes where the function that's on top switches across the interval. In fact, that's going to come up in our next example. We're going to see one where it does switch, and we have to account for that. So we're going to come back to that and deal with that here in the next example.